Hello and welcome everybody to the San Antonio Cloud Computing Meetup Group. Tonight we have a very special guest, Rosemary Wang. Rosemary has spent most of her career as an infrastructure engineer from data centers to public cloud. Most of the time you'll find her pairing with infrastructure engineers on code or application developers on systems. She enjoys open source projects, especially when it involves integrations with other ecosystems. Besides solving infrastructure puzzles, she's a mentor and aspiring apartment gardener, which I think we all know how difficult that is. Rosemary works to bridge the technical and cultural barriers between infrastructure, security, and application development. She has a fascination for solving intractable problems as a contributor, public speaker, writer, and advocate of open source infrastructure tools. Recently, Rosemary has been writing her book, Essential Infrastructure as Code, and we will be doing a giveaway on that at the end of the stream. And when she is not drawing on whiteboards, Rosemary valiantly attempts to hack stacks of various infrastructure systems on her laptop while watering her houseplants. So needless to say, Rosemary is awesome, and we're super happy to have her here. So I'll give it over to you, and if you have anything to add to that, go for it.
Thanks, Kellen. I appreciate it. That's a wonderful introduction. And if you're interested, not in the book, there's a giveaway, but also there's a promo code. The publisher was kind enough to offer something. If you're interested in purchasing it or anything else on Manning, you're welcome to try that promo code. All right, so let's get started. The first thing that I wanted to focus on today was defining zero trust security. I hear the buzzword a lot, and even I was curious. I've heard it a couple times, even before I was working in the cloud space. I was like, what is this? It turns out it's a concept, and it's definitely an approach. So today I wanted to talk about an often asked question, which is how do you automate an approach to zero trust security, right? Because you can have very, very narrow security restrictions, but you have to automate it in order to achieve it. So we're going to talk about what that looks like today. If you can switch to the slides or include the slides as part of the view. As we go along, if you have any questions, feel free to drop them in the chat. I will answer them as we go along, and Kellen will be able to forward them to me if I don't notice them in chat first. So feel free to keep asking the questions. All right. So the story starts when I had a DevOps wish list. And I had a list of things that I wanted to do when doing DevOps. We can talk all day about DevOps. That's a whole other discussion in the next hour. But the reality is that when you think about DevOps, you have a couple of wish list items, which is to use the cloud, use software as a service, a managed service of some kind, anytime, any kind, just to make your life a little easier in the cloud. You also want to use new software architectures. I know, new shiny toy, microservices, amazing thing. I mean, microservices probably isn't new and shiny anymore, but you want to use the latest and greatest new software architectures. It could be serverless. It could be anything you think of. You also want to reduce time to value from a metrics view in DevOps, right? Combining the practice of development and operations together. The hope is that you reduce your time to value for any feature you deliver. And you also want to reduce your mean time to recovery. So hopefully your platforms are amazing and you recover quickly. The thing that's not on the top of your mind is that, well, somehow or another, you might deploy something onto the cloud. Things are working, data's processing into your system. You suddenly notice there's a big alert and you realize what your application has been doing is, well, forwarding information to a Bitcoin miner. And the reason why it's done this is that maybe you were a little remiss in your wish list and you somehow just forgot security in the mix. So you allowed all inbound TCP, and the result is that, well, now you've got a Bitcoin miner contacting your application. Really scary, right? Fortunately, you had some semblance of a security mind, and you said, okay, well, I have my cloud. My cloud needs to deny some traffic, right? It needs to make sure that I'm securing it, make sure that all the traffic's going in the right place. So you disallow outbound TCP to certain, and you only allow it to certain subnets, right? In this case, 10.0.0.0/16. This isn't really adequate security posture. Let's be realistic. I mean, you can say allow all inbound traffic, but your a Bitcoin miner is still accessing your cloud instance. It's still suspicious. It's still something that's compromised your system. So what do you do? Well, as Kellen mentioned, I have a lot of information on this besides that. And I think it all comes from all of these learnings that I discovered when trying to implement and basically do anything in cloud and realizing that, well, on my wish list, I forgot security. As I mentioned before, if you are curious to learn more about the specific book I have, it's on infrastructure as code. There's a code there. But if you also ever want to reach out to me, you have my contact information. All right, so what's zero trust security? It boils down to 4 words: never trust, always verify. In security, it's common to say never trust, it's always just say like verify, trust but verify, right? Zero trust is taking a very different stance, and that's saying never trust and always verify. Well, there's really 3 goals to zero trust, right? It's not just never trust, always verify. There's actually 3 components to it. The first is authentication, and that's the question of who are you? There's authorization, which is, can you do this? And the third is audit, who did what? So when we talk about never trust, we think about authentication and authorization overlaps a little bit with verification, like authorization and audit. Right? So all of these 3 goals overlap with each other, but ultimately you need to think about all 3 in order to understand zero trust. There's a big problem though, and the challenge with implementing zero trust is identity. And I think this is not just about zero trust in general. It's about security overall. Identity is complicated. Identity has no unified model, and the attestation, the identity attestation piece, knowing that your identity is correct, well, it's even more complicated, right? And so when you think about identity, there's actually 3 types of entities that you can identify: a person, a service, and a machine. So in the cloud, when you have a person, a service, and a machine, well, identity gets even more complicated because all of these are different across multiple clouds, multiple platforms, multiple managed services, right? So if you're trying to do your wish list of items and you're trying to deliver cloud infrastructure, well, you got to think about all 3 of these types of identity. So here's the reality, and this is the rude awakening that I realized. Zero trust is asymptotic. So mathematically, it can approach 0, but never reach it. You're never going to have perfect zero trust. But you could get really close if you solve a little bit of the identity problem. But again, the identity problem is challenging. It's a bit of a heuristic, right? So if we talk about a little bit of math, we're never really going to be perfect, right? It's not going to be truly, one unified model for identity. But we might be able to get close if we apply a couple different techniques and patterns. And the key to doing all of this is that previously we treated identity as static, right? We treated identity in some ways as one way and one identity and one verification and one attestation. But in this cloud space, identity is sort of static, but actually very dynamic, right? So services change IP addresses. Your load balancer in AWS might not have the same IP address anymore, right? And in that case, you have to automate identity for ephemerality to account for some of that stuff, the dynamics nature of some of these components. So think about the automating identity for ephemerality achieves almost zero trust. So we're going to actually not talk necessarily about the tools and the direct frameworks to implement zero trust, but to think about it from an automation view. What are the things that you need to automate or you need to understand to automate and get a single layer of identity, but account for ephemerality? And that's really challenging. So we're going to talk about 4 different kinds of automation today. First is infrastructure as code, second is policy as code, third is secrets management, and the last is identity management. All of them are a little bit different, right? We usually treat each of these topics in isolation. For example, I do one talk about infrastructure as code, I do one talk about policy, one talk about secrets, one talk about identity. But let's put it all together from an automation view, right? As a project view, what do you need to automate in each of these pieces? Well, it actually even boils down to 2 subsets, right? The first piece of automation tends to be a static identity configuration. So you're looking at static identity and trying to figure out how to automate the configuration in a way that that static identity accounts for any other upstream ephemeral changes. You also have dynamic identity management. Dynamic identity management, at least in my view, is a second part of the automation piece, right? It's dynamic. It's responding to events that are happening in your system and then managing the identity based on that. So there's two pieces to it. We'll cover the first part, which is static identity, and then we'll talk about dynamic identity management. All right, so infrastructure as code. I'm going to boil it down to try to apply software development practices to infrastructure. We could debate all day long about whether it's infrastructure as code, infrastructure as configuration, or the like, but the practices and approaches are, generally speaking, fairly the same. You're using version control, you're managing your infrastructure configuration in a way that you're able to collaborate across teams, and you're applying some of the software development practices like testing, integration and understanding integration, decoupling, in order to scale your infrastructure. And in cloud, it's really very important to do this because it's almost impossible to track every single component of your cloud infrastructure. So infrastructure code, very, very important to implement. We're not going to look at infrastructure as code. We're going to look at the implementation of infrastructure as code for identity, right? Let's think about someone accessing AWS. If someone is trying to access AWS, you might give them an identity and access management policy that is for system administrator. As a system administrator, they have access to edit components, not access billing, but edit some components. When you look at the user access model, however, across GCP, it's a different role, it's a different data model. You'll notice that these are declarations in Terraform. That's less of the concern. The focus is that the name of the role in GCP is roles editor. It's roughly equivalent in identity and access management policy to AWS's system administrator. But look, different syntax, different approaches. To make it even more complicated, in Azure, the role definition is called contributor. So you've got roles editor, system administrator, and contributor, all of which are very different, right? And sometimes have different nuances as well in identity access management. So the user access model that changes across clouds is really difficult to manage. And I get a question really often, which is, well, why can't I just have one data model for all identity and access management? It's kind of the reason why the network Yang model didn't really work, right? It's not always quite that easy to have a unified identity data model across all of these platforms. So to make it even worse, if you're looking in the Kubernetes space, you have a whole different access control definition than any of the clouds. So imagine if you're trying to secure identity, secure access to your platforms, but you've got to learn 4 different kinds of schemas just to do it. I mean, are you incentivized to do it? Probably not. So the answer is usually to automate it. And the way I think about automating this, especially if there's no good workaround or I can't layer something on top of it, I use the prototype pattern. I call it the prototype pattern, borrowing from software development. But the idea is that I'm adding a layer that maps the identity to the platform. So I'm creating a prototype to map specific identities to platforms, right? So example of this is, remember that I had the 3 different platforms, GCP, AWS, and Azure. GCP was editor, AWS was system administrator, and then Azure was contributor. So there's the 3. Rather than say, I'm going to declare a model for each of them, what I'll do is I'll abstract that away. I'll say, I have a set of access mappings. This access mapping has a set of predefined roles that I'm mapping for each type, right? So as someone who's in my organization, maybe I use the terminology owner, editor, and reader. And that really makes sense to me. It doesn't matter if I'm a security engineer or I am in compliance or I'm a DevOps engineer. I am actually going to take the same language and I'm just going to use this prototype to map to the provider-specific language, the cloud provider-specific language. You can do this with SaaS, with any software as a service as well, right? You preserve these mappings so that someone who's looking at it will always be able to understand what kind of roles people have, and you offer a layer of access control that's a little bit more unified. when you actually implement this, you're going to look at a list of users, and you can pass in something like owner is an operations engineer, editor is an app dev, editor might be a manager as well. You don't know. There's a whole bunch of them you could pass in. But the idea is that you abstract this away and you make it a little bit more agnostic to the cloud provider or the identity access management schema. All right. So the reason why this is very important, and the reason why you might want to consider adding a layer on top, is that it's offering a layer of immutability for security. So if, let's say, you have someone who is no longer with the company, but a bad actor has used that identity and is trying to exploit the system, you can remove it, or you can create a whole new identity mapping, so to speak. And that way you isolate the old environment, recreate the new one. So the idea is that you're able to reproduce this, but you can pass in any number of parameters and you kind of grow. Now, it's a primitive implementation. You probably want some other kind of human identity management system on top of this, especially if you have hundreds of people. But the thought is that if you have a couple people who need access to software as a service, you're getting started into it, this is a good way to make sure you abstract away the important identity pieces and then pass it to the specific clouds. So to show this, I'm going to show secure access management with infrastructure as code. This is a little bit of code. Don't worry too much about it. But what I've defined is a couple of users who need access to my cloud system. I have a secure access management tool called Boundary here. It's open source. But what's more important is that I'm declaring the access control system and the identity using variables and using infrastructure as code. So for example, the operations team has a username ops, the products team has a username app dev, and the leadership team has manager. So I could add myself to the operations team. And if I add myself to the operations team using infrastructure as code, I can commit the changes and add Rosemary to operations team access. What this will do is that if I have a prototype available, this will push changes to any of the cloud providers I might have. This could provide, sort of a nice interface for me to push changes to any access management tool or any access management definition. So in this case, what I'm showing is configuration of Boundary itself. So me accessing Boundary. For those who are curious, basically using the infrastructure code component, I'm running all of this together. It's running some plans, dry runs, etc., and it will add Rosemary to the user group for Boundary. Now, I could set this up to do this to AWS, which is what this is hosted on. I could set this up to do it to any other software as a service platform. But having one layer and one declaration of all of the identity that you need for specific platforms is one way that you can remove and automate the identity challenge a bit. So I'm just going to apply myself, give myself access. All right. So let me go back. So while it's configuring, that's a short example. There are many, many more. But if you're curious specifically on the infrastructure as code piece, do let me know. As a caveat, I did want to include a slide on every single segment of this. And the thought is, what do you include, right? What should you include when you do automation for zero trust? Well, if you think about it from an authentication, authorization, and audit view, make sure you include your infrastructure identity, management, application, and user identities in there. You want to include authorization. So that's networking, identity, and access management, which is what we briefly showed. And then the way in audit, we sometimes forget this, but you do want to enable access logging and monitoring as well. And all of that will offer sort of the initial packaging for static identity configuration. All right, I'm going to pause for a moment. Any questions before I move to policy as code? All right. So the second configuration to think about for static identity is policy as code. So we talked about infrastructure as code. Policy as code is kind of required in order for you to do, infrastructure as code is kind of required for you to do policy as code. And this is, I think, more of the verify everything piece. So if we thought about infrastructure as code, it's trust nothing, meaning that we have an immutable approach to infrastructure. Then we can actually think about verifying everything, which is policy as code.
Oh, Rosemary, we had somebody asking about if they would be able to get the code examples after the stream, which I'll let
Yes.
you.
Yes, you will be. I will have a link to the code example. I will also paste them into the chat after the stream as well. The links will be on the last slide. So you can collect. There's going to be 2 separate repositories we're going to be working with.
Thank you.
Thanks, Kevin. Awesome. So policy as code is a really interesting approach to verifying everything. And what are you really verifying? You're verifying the infrastructure as code, which is the static identity configuration. So you need both. You can't have policy as code without the infrastructure as code. Sorry, everybody. I have whole talks on this, so I'm just going to breeze through it a little bit and give the overall crash course on it. But in order for you to do policy as code, you have to have infrastructure as code and focus the infrastructure as code on managing the identity and access management of a system, right? Once you have infrastructure as code, you're able to conduct static analysis. This is unit testing or code scanning. So if you think about it, if you are familiar with the software space, you might write code and you might scan it. You code scan it for any vulnerabilities. Very similar approach for infrastructure. Now, the interesting thing is because you've defined identity constructs and access mappings in infrastructure configuration, you can do some pretty neat things with analyzing that information. Kind of fun. All right, so then we also have deploy it. That's the next step after you've deployed the live infrastructure. Most folks don't necessarily include this as policy as code. I do, because I think it's 2 important parts. There's not only the static analysis, but there's dynamic analysis. That's live infrastructure scanning. So if you can think of the static analysis as identifying whether or not some identities are correct, your access management isn't just giving everybody administrator for some reason, the dynamic analysis is really good for a break glass scenario. You're defining some policies to say, hey, if I see someone being granted root privileges to my, let's say Google project, then I should flag that, send an alert, and say there's something wrong. Or if you're digging into access logs for a cloud platform or software as a service, if you notice someone that's logging in and they're not supposed to, then you also have a way to use dynamic analysis or live infrastructure scanning to alert teams on that. So it's a little bit of both. There's also 2 kinds of terms you'll hear from the security, at least from a security practice view. You'll hear a lot about shift left security testing in policy as code. Shift left, I think, is more commonly identified with policy as code. This means that you're not applying it to live resources. You're just applying it to the one other side. The other side is vulnerability management. This is something that we can put in the bucket of vulnerability management for servers, put it in the bucket of vulnerability management for even infrastructure configuration. And if someone goes in and accesses something that they're not supposed to, right? So there's 2 parts to policy as code. I always go through the tools for this because I think it's there's just tool sprawl everywhere. If just as much as it's hard to manage identity and thus get close to zero trust, it's really hard to manage your security tool set when it comes to scanning for or identifying compliance with policy. So you can use programming languages. That's what I'll show today. Terraform has a couple of tools, including Sentinel. Chef Inspec is a common one that I see with policy. There's also some platform extensible tools on the static analysis side. So they'll analyze some static configuration and identify whether or not they're conforming to best practices. So there's a list of tools for anyone who's interested. For dynamic analysis, it's actually even more interesting, and this is the stuff I really like. When you go into most of the cloud providers now, there's an inspection tool that the cloud provider will assess what API endpoints you've used as that user, right? So a user might own AWS EC2 or Google Compute instances or Azure instances, and they only will access that API. You get a notification that, hey, they only used 300 out of 5,000 permissions that you've given them. Maybe you should think about narrowing it down. And this analysis is really powerful. It's more dynamic in nature, and it's understanding what people are doing over time and allowing you to implement least privilege for identity. So that's actually really cool. That's one of my favorite things. There's also some other inspection tools like Forseti, Inspector, Azure Security Center, kind of. And then there's some third-party tools, for example, that will identify whether or not someone has gone into infrastructure and made changes to it. For example, open a network that they're not supposed to. And there are also a couple of folks who are making some suggestions in the chat. Just for the sake of this playback, Checkpoint CloudGuard also has static and dynamic analysis for serverless. Thank you very much. So there are many tools. Every time I go talk about tools, I get a new one. And today I learned a new one. In general, if you are interested in industry standards or specific security standards, there's one place that I recommend you go, and that's NIST for any benchmarks or a repository appropriate to your platform. I think this is the best way to approach looking at an industry standard for your identity and access management. So when we talk about zero trust security and we're looking at what's best practice, sometimes it's hard to know what that looks like. So you should probably check out some of the specific standards for your target platform, and NIST has that. Okay, so I'll show you what it looks like to check policies in secure access management. So remember that I added I added myself to, let's say, the operations team, but I don't want to necessarily give everybody access, and I don't want everyone to have just plain old anonymous access to my dashboard, right? So I do want to check that. All right, so I'll show you some of the policy that I've implemented, and then we can talk a little bit about why I ran those checks. So most policy as code retrieve information from some kind of metadata output. In this case, I'm using Terraform state. So this is what you'll see on this JSON. This is the state of the infrastructure as per Terraform. You can do this with, let's say, the live API JSON if you want. You could do it with any number of things. But in this case, I'm just using the state because it's a little bit easier and I can actually check what is going on. And this is checking the dry run capability. So if you're familiar with any of the other tools, you might just say, I'll output some dry run and then grep for the information you need. But in this case, I get a JSON, which is kind of nice. So imagine I'm a security, I talked to my security team, and the security team tells me, hey, well, there's a couple of things we don't want people to do, right? And we want you to make sure that they don't do it. And the first is global logins should allow auth, but no one should be able to access anything other than auth, right? And so in the case of Boundary, which for me, it's a secure access management platform, it's an open source tool, you may not know too much about the grant system or the access control system. And my security team is able to communicate to me, this is the policy we expect you to have. What this policy says is that someone can go to the main dashboard and they can log in, but that's about it. They can't go and see, all the servers you have. It's locking it down that they can see the dashboard, and that's pretty much all they can do. And so here, I don't even have to know necessarily about the platform or the underlying platform. That information is something that a subject matter expert has been able to decide and provide me and empower me to make those decisions about identity. So automating that becomes really critical. And part of this here, you'll notice it searches and it asserts, it does checks for these grant strings. The point is that I'm using a testing framework just to check if this makes any sense, right? So someone has gone in and automated this for me. I don't even have to know what the grant system looks like. I don't have to specialize in any knowledge of the tool, right? If I am curious and I want a best practice, and this is something you can do with any of the benchmarks that NIST lists in the repository, you can go in and examine the best practice policy you should be applying to for your identity. So here I've got a global login, allows auth, and I'm able to test that. The other policy that I have written, the JSON for that information, is that I only want operations to have admin. I do not want my application team, for example, to have administrative access. Only operations team from an identity view, that group should have access to all the resources that are being managed by this tool. And in this case, again, I don't necessarily have to know the details of boundary itself, but someone in the security team, someone who has more subject matter expertise, is able to identify, well, we'll always establish a project admin role and boundary. And we need to check for whether or not those principal IDs match the operations team. So as long as there's just the operations team, which is exactly what this is showing, assert that the group name is just the operations team, it's not anybody else, that's really, then we know that it's good, right? And so when you actually run this, what you're able to do is identify whether or not it passes, whether or not it's good, it's bad. If you want, just for the sake of, just for fun, we can open the plan and I can change this up a bit. We can say, let's see, that we'll change the grant, for example. So we'll let everybody have read-only. If I can find it, let me look. Global and non-listing. This is not something you should do, but imagine if someone did try to do this and they were like, oh yeah, let's just do it all. So I will just tell everything, just do everything, right? Actions do everything. Any identity can do anything to it. And let's hope that that fails, right? So it tells you, wait a second, you know, what you've done here is you've allowed everybody to do everything. That's not good, right? We expect you to just do list. So policy as code is a good way to communicate and express some of these identity specifics in an automated way to someone else. Okay. So what should you include when you think about secure, you know, at least from a security view, policy as code? Well, you can think about a couple things. First, think about password and MFA policies. I think we all at some point have acknowledged that this is a good practice. But when you have policy as code, it makes it much easier to enforce those practices. So if you've ever tried to implement MFA or turn on MFA in AWS without a single sign-on or an identity management tool, you might find out that MFA policy is a little tricky and you don't necessarily get it right every time. So having policy as code and having some expertise to communicate how exactly you should turn on MFA is important. On top of that, it's a good way to think about managing machine access to services. So if you have policy as code and you have a machine that needs to, let's say, an EC2 instance that needs to access the API to describe all the instances, you can use policy as code to enforce just that policy. You don't allow that identity or that machine identity to access more other than maybe EC2. If they want to access a cache, maybe, then you can tell them, hey, you have permission to access a cache. But it's very easy just to say, oh, well, let's add every role onto a machine. And it's not practical to do that. But least privilege is very difficult from an identity view. So make it easier by automating it. Authorization involves a couple things. Same as before, though, networking, identity, access management, and libraries, right? Whether or not libraries have access to do something, whether or not your network has access to, is supposed to have access to something. Maybe you might have a policy that says no open TCP, no UDP traffic, no ping, no ICMP traffic, right? Be specific, have the policy that checks that. Finally, auditing. Policy as code is like, is there an auditing component to it? And I had to think about this a little bit carefully, but policy as code is hard and is also challenging in other ways. And so your identity, as I pointed out, is your identity has to be optimized for ephemerality. And as a result, sometimes it changes, right? Some of the restrictions you thought were important before might not be important now. So a good example of this might be, maybe I am a developer and I previously didn't have access to Amazon SNS or SQS. I didn't have access to the queue service. But later on, you know, the team starts to develop some expertise, and it might be more important for me now to have test access to queue service, and my identity should be allowed to have it. Maybe not my team, not adjacent team developer, right, who doesn't need it, right? And in which case, maybe there's a different type of policy that's required. So divide it into a hard mandatory, soft mandatory, and advisory policy type, right? This accounts for the various types of identity. You can be specific, but also have a little bit more broader general enforcement approaches, so that, you know, let's say a hard mandatory is no production should communicate with development. And that should never, ever, ever be the case, right? But maybe you have a soft mandatory. Some teams should have access to the queue service. Other teams don't. And then advisory is like, maybe there's some better, that here's a better way to do it from a policy view, but you're not obligated to implement it. So audit is a little bit more complicated, but I think zero trust with policy as code, with the policy as code automation in place, helps drive toward these nuances in identity, right? So it gives you the flexibility to change it over time. Okay, so we talked about static identity configuration. I'm going to pause for a second if there are any other suggestions or questions. But the fun part about infrastructure as code and policy as code is that there's a ton of independent resources on them, but putting them in the context of identity is not always the easiest thing, right? So it's easy for someone to say, use infrastructure as code. But in the case of identity, you have to make the changes to unify the layer yourself, right? So any identity that you have that you're not able to consolidate across different tools, you'll need to somehow do some kind of access mapping or identity mapping for. On top of that, you can further emphasize the important policies and communicate the identity and access control requirements using policy as code and enforce that. Okay. So now we'll talk about what I think is the more fun stuff. I know it's opinion, but dynamic identity management, I really struggled to put a name to these things, right? Because it's kind of weird, right? Secrets management, identity management, we talk about them separately, but they're actually a big part of trying to get a more secure system. We just don't really talk about them as a way of addressing dynamic identity. Okay, so let's talk about secrets management. I think this is more of the trust nothing aspect of dynamic identity. Secrets management is a way for you to allow a centralized place to revoke and rotate secrets, right? So this is very dynamic. You don't have to have the static secret for everything. So goodbye, static database password. Hello, rotated password every 2 seconds. Why you would do that, I'm not entirely convinced. But if you wanted to, you could do it. It's a quick introduction to secrets. Secrets, they're everywhere. There's nothing that you do that isn't a secret. And most secrets are, in fact, tied to identity, right? If you think about machine identity, that's SSH or a password. If you've ever tried to SSH to a virtual machine instance, you might notice that it requires your identity in order to do it. And even if it's a password system, you have to have an identity system for that too. API and UI endpoints, also identity related, password or token. Services are usually token. So if services means like there's a machine or there's a process running on the machine, it needs to authenticate to another service, use a token. Machine to API endpoints often involve tokens as well. You also have data in transit, so that's SSL certificates. Data in transit is really interesting because, well, it's not really identity per se, but you do actually need to identify who has access to decrypt the data in transit. So it is actually an identity problem too. Data at rest is also something that you might encrypt with an encryption key. Also an identity problem. Who has access to decrypt that data that's sitting in a store somewhere? Well, you don't know. So secrets are actually inherently tied to identity. And updating secrets has always introduced friction. And it's not to call this out as a good or bad thing, right? Hugops and all. But, how many of us have gone through this or heard the horror story of like, oh, someone forgot to renew their TLS cert and things went down. Updating secrets always introduces friction, right? And part of the problem is that there's a really weird dissonance between identity and the secret itself, the content of the secret itself, right? The fact that it's not able to verify that identity anymore is an indicator that that system is not accounting for ephemerality or something that's more dynamic, that's changing. So how do we deal with this? Well, traditionally, the way you would deal with this manually is that you regret everything. And I joke on this sequence of events. I keep bringing it up because I think it's rather entertaining, but also everybody I've talked to is like, actually, this is my life. If you compromise a secret or you update a secret, you quickly regret everything because you broke something. And then you decide, all right, well, fine, I'll revoke the secret and I'll rotate it. Now I have to use good old find and replace. to reference every instance of that secret and replace it, right? So that is because the secret's not tied to identity. It's not tied to anything. It's just a secret that you know it exists. Its identity is effectively just the name of the secret. It's not actually tied to the machine. It's not tied to a service. It's on its own. So when you start to introduce the idea of identity, who has access? You have a way of identifying the secret itself and making it more dynamic, right? So you can eliminate the regret a bit. And then you can defer the rest of the steps to a secrets manager to help facilitate the changing of secrets. This sounds easy. It's not. It's actually pretty difficult. But what a secrets manager is effectively doing and what dynamic identity management is offering is a layer for you to assign identity to some entity. And in this case, this entity is a secret. Okay, so secrets management securely introduces and updates all the secrets for machines and services. Pretty straightforward definition. But we can look at this in practice, right? What does it mean for identity? What does it mean for machines? Why does this all matter? Why tie a secret to identity? Well, let's look at my good old demo, not the failing policy. But in this situation, I'm going to breeze through the actual configuration a bit. But I have a couple services here. Right, and I have a couple of services. Oh dear. Oh, here we are. Oh, here we are. Okay, so I have a couple of services here. I've got a front-end application. I've got public. I've got product. The one important one that I'm going to look at is product. Product accesses a database, right? This is a service that communicates to a database. Now, in Kubernetes, machine identity, you can consider the pod, right? So this is a pod. If you're not as familiar with Kubernetes, it's okay. It's an abstraction that identifies a workload, right? So this is a workload identity. You'll see this 589B95, F9, F5. That's a workload identity. And what I've done by adding a secrets manager, in this case, Vault, to the mix, is associate a machine identity or a workload identity with a specific secret. So I'll print out the secret that it's using. I know. Everybody get scared. We're going to have a database password on the screen, but that's okay. What you'll notice is it prints out a couple things. So Vault is serving as my secrets manager, and what it's effectively done is provided a database secret. That database secret is a username and a password. There's not too much to it. So the username is a long string here, and the password is the other long string here. It is assigning that username and password for the database to the specific workload. In this case, that is my pod 589B. So that's important. It's assigning it there. I've only got one secret out there. Now, let's imagine that I deleted this. Let's be a little dangerous, right? Let's say that I deleted this. That means I delete that identity. That pod doesn't exist. That workload no longer has that identity. That means my service has a new identity for its workload. So it'll delete. It'll take some time. But once I delete it, Kubernetes, being a workload orchestrator, will recreate that workload again. So you'll notice it is once again recreating. It's got a different one, RZ9H9. So it's about 17 seconds old. It's a new identity. It's a new machine. And when you examine the same commands, what you'll find out is that it's a completely different set of usernames and passwords. Let's see if I can scroll up. Oh, no, I can't do that. It's fine. It's a completely different set of usernames and passwords. So it's issuing a new secret correlated to the new identity. Why is this important? Well, if your identities are constantly changing, you always need to be assigning or re-attesting whether or not that identity can have that secret. So thus, anytime you create a new identity, you have to relate that secret to it. So this is one of many ways that a secrets manager can relate identity to secret. If you can think about SSH keys, you can think about many other ones. But in this case, we're showing it in the context of a secret. You'll also notice that it issues a couple, sequentially a couple new leases to the secret. So it's recognizing, hey, there's a new workload coming up, and then it issues that information. So it's a very quick overview of correlating identity to a secrets manager and how that actually helps drive some of the automation and drive toward greater security. Why is this more secure? Well, first of all, you're accounting for anything ephemeral. When the workload disappears, you get a new set of credentials. So that means you're constantly rotating them. The time to live, you can limit that or you can set that. When you set the time to live, you limit potential exposure of that secret. And many, 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 many more. So that's a quick example of that. So what do you include when you think about, well, authentication? So and authentication, authorization, and audit in the context of secrets management. Well, authentication is done away with, right? You don't authenticate with the secret. You authenticate and securely introduce yourself to the secrets manager. So very different approach. You're introducing yourself to the secrets manager and you're authenticating to the secrets manager. Authorization allows you to provide least privilege and temporal access to specific secrets. So not only can you restrict who has access to what secrets, you can identify how long they should have access. So as I mentioned before, you can say, I want 2 seconds, 2-second access to my database, and that's gone. You could opt to do that, or more reasonably, you probably want to be like an hour. 2 seconds isn't quite practical. And then finally, from an audit view, you identify when a secret has been used, and that secret is correlated to identity. So you can audit the identity that's being used as well as the secret that is accessed. So it's a very important thing to correlate the two, and that's why offering a layer for secrets management at least provides the additional dynamic automation required for secrets. There is a question in the chat, I believe. And the question is, can you use Vault to request dynamic STS tokens for Kubernetes pods in AWS? So that is a little bit trickier. You can configure the AWS secrets engine. I believe the AWS secrets engine has a couple of configurations, including but not limited to access keys, etc. But we can always double check. It's been quite some time since I double checked the secrets engine for Vault. And so as long as you're able to set up so what you're doing is you're authing to Kubernetes. When you're using it in a Kubernetes pod, you're using Kubernetes service accounts to authenticate to Vault. So your service account becomes the identity to introduce themselves to the secrets manager. And you can use AWS secrets engine to issue the token appropriately. You just have to make sure your application is able to account for and retrieve the credentials based on the role. So you have access key, secret key, and security token associated with that. Yeah, so you can do STS. I'll link it into, I don't know if I can link it into chat. You may block me. Okay, but yes, you can do STS credentials, but that's kind of the second separate piece of it. It's using Vault as a secrets manager to assign the STS identity to STS identity for the application, but you still need to set up Kubernetes in order to authenticate to Vault, the secrets manager. There's a couple of things there. Okay, so last one, and that's identity management. This is a little bit harder to define because, again, I said identity was person, machine, and services. Identity management, I think, is a huge question. We talk a lot about automating identity in the first 3. We talked about assigning identity and adding abstraction layers. Like in the case of infrastructure code secrets management, we added layers to identify stuff, right? Versus policy as code, it's more of an enforcement view of identity. Identity management, I think, is also similar to policy as code, in that it is more of a verify everything kind of approach, right? So let's talk about identity specifically. Let's return back to my architecture that I had before. In this architecture, I actually parse out 2 different types of identity that I need to manage. The first is service identity. I mentioned before that product is a service. It's accessing a database. There's also 2 other services in my Kubernetes cluster, front end and public. All of those are service identities. There's also a second set of identity, and I might use single sign-on to manage access to Kubernetes or to human identity, for example, to AWS. So you can have these two different identity layers, one for human identity and one for service identity. And so human identity has a lot of vendor tools. I won't go and list all of them. There are only some of them on this slide, and some of them are like Okta, Auth0, Active Directory. So you can use single sign-on to sign on, or you can use some kind of access control and identity management layer. It's really just an infrastructure layer at the end of the day. You can think about it as a workforce identity infrastructure layer, a customer identity infrastructure layer. I mean, it's all in with the purpose of verifying identity and whether or not someone has access to certain systems. There's also secure access management, which I would say operational identity. So whether or not your operators and developers have access to endpoints within your system. So I'll show the secure access to a database specifically. We're once again going to use boundary, but the reason why I wanted to show this, at least from a human identity view, is that you still need some kind of layer of automation or abstraction just to show this. So one thing I did want to start with is that imagine that I am an operator, and as an operator, I should have access to everything. So here I've logged in as my ops team here. I am ops. I could also log in as Rosemary, but I won't do that right now. I did add that as part of our infrastructure's code. But as ops, I'm able to access certain endpoints. So for example, I'm able to target the database. I'm able to target some other stuff in core infrastructure. More importantly, maybe I'm able to target some, I can SSH into my Kubernetes nodes. And it would be important to me as an operator because I might need to debug something on the virtual machine, in which case I want to secure my access to this SSH target, right? I also might have access to my software as a service. So in this case, I had Vault, which I showed before. I'm using a cloud offering for Vault called HCP, and I maybe want to secure that endpoint as well. So all of these things I'm seeing in one view, and this is really great because I get it, well, in a layer that comes from a tool. If you use any of the other secure access management, privilege access management tools, the idea is that you get the same approach, right? It is automating and building this layer of identity for you to understand you being the ops person accessing certain targets. Now, comparably, I might be app dev. So this is me being app dev. App dev might only be able to access, well, one thing, and that is the target for the database. I can't access or SSH into Kubernetes cluster. I can't access the Vault instance or the Consul instance or any of the other tools or managed cloud offerings. I can only access the database, right? And that means that my identity is assigned to these specific endpoints. So correlating the access management from my identity to specific endpoints becomes really important for at least for all of these, at least the securing of changing endpoints in my environment. So if you can imagine, for example, if someone says, I want to access a database, that they're able to do that. If you add a new database, for example, in the test environment, you're able to change that. So for example, just to show that you're able to finally correlate identity to any changing endpoints, if I try to SSH as an application developer to the Kubernetes nodes to SSH, then I'm denied to do that, right? I'm not allowed to do that. So there's also additional registrations. You can also add more targets. So one of the ones in here, if you check out the targets, one of the ones in here is that my front-end application, I might decide to test it, right? This is pretty common as a developer. You maybe want to go in, check your UI, make sure it's all working end-to-end, make sure things are good. So you might try that first, and you only want it to be yourself. And then once you're done confirming that it works, you might just say, let me revoke my access. I don't want access to production front end. I just want access to the development one just to make sure my UI changes are good. And in which case, then you can make that change. You can update the target and remove the target so you no longer have access from the security view. So the identity accounts for changes in endpoints and secure endpoints as well. Okay. So there's more, but there's more. Finally, service. Service, I think, is really tricky. I came from the networking space, and it always occurred to me that we talk about service and networking and service as if it was the identity. So funny thing to me is that a lot of the times we treat a service's IP as identity, and it is not, right? A service's IP address is not a great representation of identity. It changes. You might change it a lot. It doesn't change. It means that the service itself doesn't mean it changes because its IP address changes. Not really. It still would be like a hello world service. And the other thing is neither is DNS. It's very common for someone to tell me DNS is the identity. That's the source of truth. Well, you've got DNS for various purposes and subdomains, etc., and it becomes a really difficult mapping from an identity view. So what's a better way to think about identity? Well, in networking, there's a thought about intent-based networking, and that's in some ways more along the lines of service, of really making a true service identity. So it's mapping an identity to any type of entity. So you could have a service that's on a container. It's still a service. You could have a service in Lambda or serverless. It's still a service. It's a virtual machine. It's still a service. Managed services are still services. Data center, other clouds also have the same exact service identity. So you're able to create a layer. Again, notice there's a theme. Part of the automation involves adding a layer so that you have an identity layer on top of all of these things. What does this mean for services? This is what you call a service mesh, yet another buzzword. But if you think about a service mesh, it is effectively an infrastructure layer that offers service identity. And just as much as we offer secrets management, for example, as an infrastructure layer for correlating identity to secrets, we have an infrastructure layer to correlate services with specific underlying workload components. So let's actually look at what this is implementation-wise. When we look at this from an implementation view, I'm using a service mesh called Consul. At the end of the day, you can use any kind of service mesh that you desire, as long as it's offering a specific identity layer on top of that. So when we examine the identity of the services, I have a service catalog in the form of the service mesh. And what it's done is registered services no matter what the underlying workload is. Now, I'm lucky. A lot of these, like front end, are, well, containers. But what's important is that because I'm able to manage a service identity, I'm adding a layer. It doesn't matter if it's a container. I don't, in this, I don't see anything that indicates to me it's a container other than it says it's Kubernetes. But for the most part, I can say, here is a service identity called front end. Front end can access public. Those are identities. It doesn't matter what the IP address of the container is. It doesn't matter what the workload ID of the container is. I am able to fully declare the intent of connecting front end to public. Similarly, if I have something like a database is technically out of my mesh, right? This is a managed database. That's what's really interesting. This is an AWS RDS instance, and it's not a container. It's running completely outside of it. What I've done is added or used this mesh as an identity layer to resolve to the database. And so by correlating this in a service catalog, I'm creating an identity for the database. It doesn't matter if I update the database later. Thanks to infrastructure as code, if I update the database, my infrastructure as code will re-register the correct database endpoint back to my service mesh. So what's fascinating about this approach is that if you can get the set of things to end-to-end be automated, you do end up having almost a singular layer, and you consolidate a lot of the identity challenges into basically a couple different tools. For those who are more curious as well, you can always add more information and more control over that identity. So by extension, because you're adding a layer of identity on top of everything from the service view, you also get the ability to control traffic a little bit more carefully. All right, so, okay. I will say one caveat to this. If you are adding an identity layer, it does not mean that it is your single point of security. You must have compensating controls in this. And the hope is that you use either some kind of infrastructure as code or additional automation that takes the information from the service catalog and synchronizes it to sort of the baser level network policy and infrastructure. So if you're in the Kubernetes space, for example, you need ways to synchronize anything on the service mesh layer, on the identity layer, to other constructs of identity, including container network interface plugins like Cilium, Calico, Weave, etc. And more importantly, you need to be able to take those service identities from the service mesh and eventually synchronize them to physical devices like firewalls, security groups, etc. So all in all, there's still a lot of work, I think. There's still a lot of work to think more carefully about your network security and adding different tools as well as different compensating controls to make sure that your network policy is truly secure and to truly be zero trust, right? To make sure only services with valid identities are communicating with each other. There has to be a more specific sort of layered approach to it. And you also have more automation as a result. So that's something to keep in mind. I think there's some room to grow there. But what are we, just to summarize, what do you include when you think about identity management? Well, it's one platform for human and service identities. You can use something like Okta to do something like human identity plus auth servers for API. You could do that. Authorization is multiple layers for policy control. As I mentioned before, you've got many layers, so keep that in mind. Audit, track your human logins as service-to-service communication. If you're able to track and audit and observe the whatever traces are coming out of your service-to-service communication, as well as who's logging in, you can verify everything. All right. So I went through all four. I know it was quite a bit, and it's a little bit later, so it might be a little bit much right now. But hopefully when you come back to it, you think a little bit about how you can automate to approach zero trust, right? So all of these things we talked about might be spoken about as independent practices, but at the core of it, they're automation. And you can apply this automation to solving some of the identity challenges that you do have. If you approach some of the identity challenges and automating those pieces with adding new layers of abstraction, adding better practices, treating a lot of these policies as code, then you get a better chance of approaching zero. So in summary, zero trust is asymptotic. Don't expect to be zero all the time. It's going to take time. You're going to find yourself building a lot of extra automation just to achieve sort of a unified identity layer by yourself. And it is limited by the operational challenge of identity. Identity right now is not just a theoretical challenge. I think it's truly an operational challenge. Unless you built your own, like one huge identity layer to rule them all, it's not exactly the most practical thing. So you end up cobbling a lot of tools together and making them interoperable. And finally, automate identity for ephemerality. There's two ways to do this, right? You can add the identity abstraction layer. So in the case of, let's say, service identity, it's service mesh, secrets management, or let's say in the case of infrastructure as code, a prototype pattern to map access and identity. But you also want to automate the abstraction as well. So that's something to think about. Can you automate the abstraction enough, the abstraction of identity enough, that you don't necessarily have to think about it? You have one language of identity to talk about your entire system. All right, as promised, references to these code repositories. The first one is an introduction to zero trust from the blog. I think it's a great explanation. The second link, HashiCorp Stack Demo App, is this architecture. You're welcome to go through the entire architecture. It's a rather large one. I think there's there's two EC2 instances, an EKS cluster. There's a lot of pieces to it. And definitely if you have questions, reach out. But it shows these things and I continue to add over time. There's also the policy as code piece, which is separate. And so there's a 050 trust. You're welcome to check out the Pythonic approach. There's multiple examples in there, including like various DSLs from various tools. So definitely check it out. And then if you want the full explanation end to end of all of the tools specifically, you can check out the last link there. But today, what I really wanted to focus on and answer the question was, what do I need to automate to approach zero trust? What does it make sense to do? What are the tools and the frameworks we have available and these ideas that we have available to make it a little bit easier? So hopefully you found one of them useful, or at least a different way of thinking about identity configuration and identity management. And with that, any more questions, feel free to drop in chat, and I'll turn it back to Kellen.
Okay, thank you very much. That was awesome. I no surprise, but I guess we will. Let's see. I know we wanted to do the giveaway, and there was something I was thinking about, but I have lost my train of thought. Oh yes, I think if you send the any links over to me, I can post them to the chat. So I mean, we may want to try that. But anybody in the chat, I guess, type the word "win," and we'll. I'll do the drawing, and Rosemary can answer any questions while we're doing that.
I'll drop the other two links in the chat. I think I saw one come in. Can we use Terraform for Kubernetes network policy management? You know, you could. There's a lot of pieces to this, right? So if you think about policy management in general in Kubernetes, there's a lot of constructs that they offer out of the box. So that's like pod security policy, which pod security policy, I think, is a mixture of literally policy and some points of identity. That was definitely something fascinating. And then there's also the sort of like the other piece of it, which you could have Terraform on top of that, which just controls the policy, the network policy management as well. You know, yeah. So PSP is going away, and that's why it's a little bit like network policy. I think it will heavily depend. You can manage the construct in Terraform, but what I see the problem with network policy is that it's not well consolidated. Like, it's kind of disappointing to me that the Kubernetes community hasn't figured out like a controller or something that does automation and orchestration to network firewalls, et cetera. There isn't really a project for it. You can use, let's say, Kubernetes at the time of this. You can use something like Kubernetes service catalog to implement your own, but there really isn't one. So network policy, I think with the exception of Juniper, isn't exactly on the firewall level. There's network policy on like Cilium, or I believe Cilium and Calico. But yeah, it's not quite there yet. So I think there's a lot of work to be done there. But it could very well, network policy could be very well your identity, your service identity layer. It's just not. I kind of wanted more. I kind of wanted more in that space. So we'll see what happens. But yeah, there's another policy one that I just remember from Kubernetes, but I don't remember.
I was going to say also, if you're not following Rosemary on Twitter, definitely do that. I said, I think just watching this, you would know that she's an authority and definitely knows her stuff, and is a great teacher at breaking it down and making, for people like me who may not get it the first try, can get it broken down and understand what actions do we need to take when we hear certain phrases and things over and over again. So
thanks, Kellen. I appreciate it. Yeah, it's been, I will say this has been a lot of learning from my end. Grill away. I mean, I'm always hearing about new tools and new things from other people as well. And my hope is that, you know, as folks pick up more and in this space and figure out their own automation, I ultimately learn from them as well. So yeah, it's been
I'm sorry. I'll go ahead and pick the winner here, if that's cool. I've got the 4 people. Looks like we've got 1, 2, 3. Oh, how many do we have here? 1, 2, 3, 4. Okay. I'll go ahead and spin the wheel of randomness here, and I will announce who it is. Jackie is the winner. So I will post the email here that you can contact me, and I'll send that code to you. Let's see if that shows up there. And then I know we have a discount code as well. You want me to go ahead and post that?
Yes, if you could post that. I believe they said it was anything on Manning, so let me know. I think it's 35% off or something. I don't quite, yeah, just let me know. You can reach out to me if you're like, oh, this isn't working. But I believe it's 35% off. And the book is in early access right now. There are there's one whole chapter on cost compliance and security. So that's the one everybody, I think, is.
And shout out. Sorry. And shout out to Rosemary and Manning for those codes and the giveaway as well. That's so cool. So I greatly appreciate it, and it makes it a little bit fun too. Okay. Well, if you have any other parting words, I guess I'll go ahead and sign us off here.
Yeah. Tune in to more cloud computing, San Antonio, fantastic group. If there's, I hope we go to in-person events again. In which case, I hope we at least get to see the community more in person.
Sounds good. Thank you for joining us, Rosemary, and thank you to everybody who watches, including those who watch the recording. So thank you, everybody, and have a good night.